From the question, it is said that find the tension in cable OA, OB, and OC, and the different situation is on. This is the 30 degree, this is 45 degree, this is 60 degree, this is pulley, and this is a massless contact, or a point where these all cables are joined, and the mass, this weight is given 1400 newton, and this weight is given 200 newton. Um, so to draw the tension in these three cable, we have to first draw the free body diagram of different body and point. For example, if we draw the free body diagram at point showing all forces, then if consider in this cable tension is T1, and in this tension is T2, and in this tension is T3, and in this tension is T4. Now string is because now because this is 60 degrees, so this will be also 60 degrees, so there will be two components, T1 cos theta and T1 sin theta. Again from this, if we see here, because this is 45 degrees, so this will be 45 degrees, so we can write T2 sin 45 into T2 cos 45. We are breaking it into perpendicular component. And again, if this is T3, and this angle is shown here 30 degrees, so in one component will be in this direction, that is T3 cos 30, and one component will be in this direction, T3 sin 30. And now the weight over the, because this is massless, so there is no need to show the weight. So the vertical, here we can apply the Newton's law for equilibrium condition. This is for horizontal equilibrium and for vertical equilibrium. For horizontal equilibrium, we have to write sigma fx equals to 0. Now from above figure, this direction is taken as positive, and then T4 plus T1 cos 60 minus T2 cos 45 minus T3 cos 30 will be equal to 0. This will be the equation 1. And for vertical equilibrium, we can write sigma Fy equals to T2. This direction is positive and this direction is, and T2 sin 45 plus T1 sin 60. T2 sin 45 plus T1 sin 60, and this will be minus T3 sin 30 equals to 0. This is the equation. Now draw the free body diagram of this body and this body. Now 200 Newton body, T3 will be in upward direction, because there is no the string is considered massless. Then T3 and this will be 200 Newton. Again for this situation 400 Newton body, again T4 will be 400 Newton. So solving this equation, putting these values and solving, we will get required answer. Now again, find all the contact forces and compression of the spring for equilibrium of the spring. Here another situation is shown. This surface is considered friction is considered or not. Okay. No, there is no friction considered. In this case, it is also the spring is compressed due to force in this direction applied because this have a component. So we can show the different force on this. because this is in equilibrium, whole system is equilibrium, so there will be many forces, and we have to draw the free body diagram of each body separately, and then solve the problem. The first is this body, a monomass body. There will be a tension along this direction, which will be passing through the center, or even not passing through the center, don't think. We can because this angle is given, so we can calculate this angle. This will be perpendicular, and if we draw like a line, then this must be alpha, because if this is perpendicular, and here it cuts, the situation is shown in the figure here. If this is alpha, then this must be 90 minus alpha, and because this line is parallel to this line, if we draw a parallel line here, then due to corresponding angle, this will be alpha. And now if we draw a perpendicular also here, then this will be, if alpha, then this will be 19 alpha, 90 minus alpha, and this is perpendicular to this line, so this will be alpha. So from this figure, if it is alpha, then if this alpha will be alpha. Now consider this surface is applying force N, so this is N, and weight will be acting in the downward direction mg. And now contact force, normal contact in this surface is N dash, on this body is, it is shown in this direction. So there will be two component, one in this direction, and because alpha is known, so we can calculate. Here it is shown N dash, the N dash cos alpha will be in this direction, N dash sin alpha will be in this direction. Now we can take the uh, uh, first considering first body the equilibrium of first body, then we have to take equilibrium of this body. So first take this equilibrium of this body, then we'll be, then from writing sigma fx equals to 0, n minus n dash sin alpha will be 0 equals to 1, and sigma fy equal to 0, n dash cos alpha minus m1 g equals to 0. This is the second equation. Now consider the block, then in this direction n dash will be, and this is alpha, so n dash sin alpha will be in this direction, and n dash cos alpha will be in this direction. Again, because a spring is compressed by a distance x, then a spring force will be in this direction. Weight, this body has mass m2, then weight will be in this direction. So considering, and the surface, that is ground surface, applied a normal force in this direction. So we can write sigma of x equals to 0, from sigma of x equal to 0, n dash sin alpha minus kx, because kx in this direction, n dash sin alpha in this direction equals to 0, and for vertical equilibrium we can write n dash minus m2g minus n dash cos alpha equal to 0. On solving this equation, we can get the desired result. Again, here the next question is write equation for equilibrium. Again, the body is in equilibrium, and here friction is considered, because it is given that the coefficient of friction is mu dash, then, and also here the coefficient of friction is mu, and body is in equilibrium, and this is alpha, it is given. Then we have different situation here. Now consider the, again we have to draw the free body diagram. This is consider this in the normal contact between this surface is n, the showing on this body, this will be in this direction, and normal contact in this body is n dash, so showing in n dash, and again this will be alpha, as proved earlier, this will be alpha from the vertical, and this is alpha, and vector will be in this direction, and due to because this has tendency to slip in this direction, so force of friction will be in this direction on this body, so it is shown force of friction F. Now resolving this in component form, because now index will be index cos alpha, and friction, because this is alpha, the f cos alpha will be in this direction, f sin alpha will be in this direction, m1g in this direction, and dash sin alpha in this direction. And now can write if sigma fx equal to 0, here if we write sigma fx equal to 0, then we have f cos alpha plus n minus n dash sin equal to 0, equation 1, and similarly sigma fy equal to n dash cos alpha plus f sin alpha minus m1g equals to 0. Again for the block, if we, because on here this was n dash, so on block it will be also n dash, and this will be the alpha angle, and here because this body will have tendency to move in this direction, so friction, force of friction will be in this direction. Yeah, force of friction is not shown. So for vertical or taking direct in this direction component, index will be 1 g cos alpha plus n sin alpha. Again f will be mu into n dash mu into m g cos alpha plus n sin alpha. Again we can write showing the different situation here. Uh, mu dash n double dash, which is surface is normal force, and here it is shown. You can write n dash minus n and n cos alpha is 0. This implies n double dash equals to t plus n dash cos alpha, equation 4, and f dash equals to mu dash into n double dash mu dash into mtg plus n dash cos alpha. These are the equations, and solving this equation we can find the desired result. Again sigma fx equal to 0, f dash equal to n dash sin